Okay, this lesson is a quick video on how to solve system of equations by graphing. So the first thing, let's understand that this is a system of equations. We have two equations, and we can solve that by finding an x and y ordered pair that satisfies both equations. This is also a system of equations, just highlighting that sometimes they're not written in slope-intercept form, but they're written in standard form. So we'll talk about that one as well. All right, so first let's just take a look at this here. Notice that you have two equations that have been graphed, okay? This is now a system of equations, and the solution to this system is where they intersect, right here, okay? So this ordered pair, which is an x value of 1 and a y value of 2, is the actual solution. So again, our solution is going to be this location, or this point right here at 1, 2. So that's our solution, where they intersect, okay? Just another example over here. Again, we have two equations that are graphed. They intersect. The point they intersect right here is at 0, -1. So that would be our solution here, where it intersects right there, okay? So again, with our answers, we put those in parentheses, and we locate the point at 0, -1, and that is the solution, okay? Let's take a look at this example. Here, you actually have to solve, or you actually have to do the graphing of the equation in order to find where it intersects. Now, these are both in y-intercept form, okay? So we basically just identify the y-intercept and apply the slope to graph it. For this first one, the y-intercept is -4, so we put a point at -4, and then we apply the slope of 1/2. That's a rise of 1 and a run of 2, and it is positive. So we're going to go up 1 unit and over 2 units and put the next point right there. And we could kind of keep going. And then we have a straight line, or a somewhat straight line there for that one. Now let's do the next one, okay? So y equals -x plus 2. Again, we have a y-intercept of +2. So we can go to +2 and put our y-intercept. +2. Then we have a slope of negative, and this is a 1 in front of the x, so -1. That means -1, it needs to be going downhill. The rise is 1. If we call that -1, we go down 1, then we would go right 1 unit and put the next point, and down 1 and right 1 and down 1 and right 1 and so on. So let's go ahead and do that. So our next point would be here, here, and then we could just kind of keep going. All right, like that. We'll draw the line through there. All right, and then you notice that they intersect here at this location. So the solution to this system of equations is 4, -2, because this point is a solution to both of these graphs. So to identify our answer, we put them in parentheses, and we have our point they intersect at the x value of 4 and the y value of -2. All right, so that's a look at graphing, solving systems of equations by graphing. However, okay, so in this example, we're also going to solve the system of equations by graphing, but notice we have one equation in slope-intercept form and one in standard form. Let's go ahead and graph this one in slope-intercept form first. It has a y-intercept of +4. So that just means we would go over here to +4, and we have our y-intercept. Then we have to apply the slope. Well, the slope is -x. That means -1, okay? That means we could go down 1 into the right 1, down 1 into the right 1. As long as we have a negative slope going downhill, because, again, it's a -x, or the negative slope. So my next point would be here, okay? Or I could keep going, okay? And then we just draw that line straight through, okay? Or as straight as possible, okay? Now, this next one here, 2x minus y equals 5, this is in standard form, all right? But what I want you to understand is that there's an efficient way, kind of a shortcut maybe, instead of having to convert this to y equals mx plus b form, the slope, okay, so the slope of this equation is going to be equal to, the opposite of a over b. All right, now the a is this first number because it's ax squared plus by equals c. All right. So again, if you want the shortcut for finding the slope, it's the opposite of a divided by b. So in this example, the a is 2. Well, the opposite of a 2 is negative 2. So we're going to have negative 2 over, and the b minus y, this is a minus 1. So that would be over negative, over negative 1. Okay? Well, if it's negative 2 over negative 1, we're just going to go ahead and simplify that. A negative over a negative is a positive, and 2 over 1 is just 2. So let's just call this a slope of 2. We have a slope of 2. All right. Well, the y-intercept can be found by taking the c, the value of c, which in this one is a 5, and dividing that by the b. And the b in this example, again, is negative 1. So we divide by the b. Or, divide by the b and negative 1. So in this example, again, very specifically, we have a 5 divided by negative 1. Well, 5 divided by negative 1 is negative 5. So we have a y-intercept of negative 5. That means we have an equation that says y equals 2x minus 5. So now we can graph that with the y-intercept and the slope. We have a y-intercept of negative 5, so we'll just go over here at negative 5 and put a point. And then we apply the slope. This is a slope of 2, so that's up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, and so on. So let's see. Let me go ahead and put a point. Up 2 over 1, up 2 over 1, and I will draw the line as straight as possible. Now, it looks like we don't have really a clean intersection, but it looks like I didn't draw my lines very well. So again, if I had to draw my lines a little bit better, you'll see that we're intersecting right there because this slope for this first one was negative 1, down 1 over 1, down 1 over 1, down 1 over 1. I just didn't draw my line really well. Let me try to clean that up maybe. All right, and you can see that it intersects. The intersection that we're referring to, or that we're looking at, is right here. Okay, and the ordered pair for that intersection is an x value of 3 and a y value of 1. So the solution to this system of equations, is at 3, 1. And that would be the answer.